Hello all, welcome back. Today we are going to solve the longest valid parenthesis problem. It is appreciated that you look into the stack video and the LeetCode problem 20 valid parenthesis video. The problem statement is this: given a string containing just the characters open and close parenthesis, return the length of the longest valid parenthesis substring. Look at the example 1. Input S is equal to open parenthesis, close parenthesis. Obviously, the output is 2. The longest valid parenthesis substring is 2. Example 2, output is 4. Yes. Example 3, output is 0. And the constraints are also given for reference. This problem can be solved in 3 ways. Number 1 is using the stack solution. This is the most preferred interviewer-friendly solution. Number 2 is using dynamic programming. If you want to exercise your DP skills, you can prefer this. Number 3 is the 2-pass counter solution. It is again the most elegant solution, but in this video, we are going to solve using the stack. Fine. So before getting into the core part of the solution, the idea is simple. Instead of storing brackets, I appreciate looking into my previous video, LeetCode problem 20, where I'll be storing the brackets. So instead of storing the brackets, here I'm going to store their respective indices. The distance between the indices gives the length. That's my answer. So I have to remember a rule and a trick. The rule is this: if there is an open parenthesis, I push. So what I push the index of that particular parenthesis. When it comes to close parenthesis, I will pop the topmost element of the stack. After popping, if the stack becomes empty, I will push the current index onto the stack. Else, I will find out the length as the current index minus the top of the stack. This is my rule. And the trick is that I will always have the stack to be -1 initially. So before starting the rule, the stack will be -1. So this -1 condition is an imaginary boundary before the string starts. So without which it is very difficult for me to find out the valid substring. So keep in mind the rule and the trick. Fine, let us go for a dry run. Let me take an example. S is equal to open parenthesis, close parenthesis. So initially I will keep stack to be -1. That is being done initially. Look, fine. Step 1, look, I equal to 0. The input is open parenthesis. So if it is open parenthesis, what will I do? I push the index 0. Now the stack becomes -1, 0. So no updation for max. Step number 2, look, it is again an open parenthesis. I push the current index 1. So stack becomes -1, 0, 1. No update for max. Step 3, look, the input is close parenthesis. If it is close parenthesis, I will pop the topmost element of the stack. So 1 is removed and the stack becomes -1, 0. Now I calculate length as 2 minus 0. 2 is the current index, 0 is the top element of the stack. So 2 minus 0 becomes 2, which is max. End of the string, the answer is 2. Yes, for better understanding, look, the corresponding indices of the string are 0, 1, 2. I appreciate you to do a manual trace with a pen and a paper for better understanding. Initially stack is -1. After I equal to 0, I push the current index -1, 0. After I equal to 1, I push because it is open parenthesis. So stack becomes -1, 0, 1. After I equal to 2, it is pop. I pop the topmost element of the stack. Fine. I pop 1, stack becomes -1, 0. Find out length. That's your answer because that's the end of the string. Fine. Done. So again, this is the visualization for the same example. Longest valid parenthesis substring length is 2. So you store the indices, not the brackets. Fine. Let's move on to another example. The input string is this. It is close parenthesis, open, close, followed by a close parenthesis. So as the trick, we have the initial stack as -1. Push -1 onto the stack. Step number 1, yes, for I equal to 0, what is my input? First input is the close parenthesis. If it is close, I pop the topmost element. So -1 is popped out. Stack becomes empty. So if stack is becoming empty, what should I do? I should push the current index. Current index is 0. So now stack becomes 0. Current index 0 is pushed onto the stack. No updation for max. Step number 2. Look what is the input. It is open parenthesis. If it is open parenthesis, I should push. What should I push? Push the index. Current index is 1. Stack becomes 0, 1. No updation for max. Step number 3. Look, the input is close parenthesis. If it is close, I should pop. What should I pop? Topmost element of the stack. Now the stack becomes 0. Find out length. How do I find out length? It is the current index minus top of the stack. 2 minus 0 becomes 2. So max is 2. Step number 4, look, the input is open parenthesis. If it is open parenthesis, what should I do? I should push the index 3. So stack becomes 0, 3. Max is still 2. Step number 5, look what happens. It is close parenthesis. I should pop. What should I pop? The topmost element. So the stack becomes 0. Find out length. What is length? Current index 4 minus topmost element 0. 4 minus 0 becomes 4. Max is updated as 4. Step number 6, look what happens. Input is close parenthesis. So pop. What should I pop? The topmost element. So topmost element inside the stack is 0. Now stack is empty. Yes, if stack is empty, what should I do? I should push the current index 5. Stack becomes 5 and max is the same, 4. Okay, so the answer is 4. Yes, so complete visualization. Look, for each indices, initially stack is -1 and iteration after iteration, max gets updated. Finally, you find out the answer. Yes, the complete visualization of the same is given in this picture. Remember, you store the indices, not the brackets. Fine. Do again a manual run using pen and paper. Find out the longest valid parenthesis substring using the rule and the trick. For this example 2, the longest valid parenthesis substring is 4, which runs from the index 1 to 4. Done? Okay. So the left side shows you the core part of the function which implements our rule. So analyzing the core part of the function, fine. The time complexity of the same is order of n and the space complexity is order of n. Any doubts? Post it in the comment section. I'll be happy to explain. Thank you. Happy learning.